Welcome to Accounting Information System. Okay, let's talk about documentation. Documentation explains how a system works, including the who, what, when, where, why, and how of data entry, data processing, data storage, information output, and system controls. Popular means of documenting a system includes diagrams, flowcharts, tables, and other graphical representations of data and information. These are supplemented by a narrative description of the system, a written step-by-step explanation of system components and interactions. In this chapter, we explain three common systems documentation tools. We have the data flow diagrams, the flowcharts, and business process diagrams. Documentation tools are important on the following levels. At a minimum, you must be able to read documentation to determine how a system works. You may need to evaluate documentation to identify internal control strengths and weaknesses and recommended improvements, as well as to determine if a proposed system meets the company's needs. More skill is needed to prepare documentation that shows how an existing or proposed system operates. So what are the different types of documentation? Okay, first we have the data flow diagram or your DFD. It is a graphical description of data sources, data flows, transformation processes, data storage, and data destinations. Next is we have the flowchart. Flowchart is a graphical description of a system. There are several types of flowcharts which include we have the document flowchart, the system flowchart, and the program flowchart. Next is we have the business process diagrams, which are graphical description of the business processes used by a company. So what are the different types of flowchart? So first, we have the document flowchart, which shows the flow of documents and information between departments or areas of responsibility. We have the system flowchart, which shows the relationship among the input, processing, and output in an information system. And lastly, we have the program flowchart, which shows the sequence of logical operation a computer performs as it executes a program. So this is an example of a data flow diagram. So the data flow diagram figure shows the process flow of the data from the account creation to the encoding of the healthcare process until the creation of the report. It also shows the different entities involved before and after the process. And finally, it also shows the repositories of the data where all the information has been saved. Another example of the business process diagram. In this figure, the business process diagram shows how the e-commerce platform performed its operation in conducting the business. It shows how the e-commerce process performs in generating possible revenue, determine its competitive advantage, identify the different products suited for the business, and determine the type of business activities or process in deploying the product and services. This is another example of business process diagram. So in this figure, it shows how the members can avail of the cashless purchasing of items, specifically in terms of the grocery items, using the e-wallet from the loan management of the cooperative. Members can take advantage of using the platform by purchasing it online and will the option to be delivered for pick-up to the grocery store. Data flow diagram symbols. First, we have a data source. So a data source and a data destination are entities that send or receive data that the system uses or produces. An entity can be both a source and at the same time a destination. Next is we have a data flow. A data flow is the movement of data among processes, stores, sources, and destination. Data that pass between data stores and a source or destination must go through a data transformation process. we have the processes. It represents the transformation of data from inputs to outputs. And we also have the data store, where it is considered as the repository of the data. And lastly, we have the internal controls. The processes and procedure implemented within a business organization to provide reasonable assurance that data is processed correctly. Assets and information are safeguarded, and applicable laws are followed. So again, these are another example of the document flowchart and its following symbols. So in this example of our flowchart, the broken line may indicate correction or rejection routine, or it could be a data transfer, which is either checking or reading the data. So this is another examples of the business process diagrams, including the different symbols. So this is the actual process of the different activities that is performed. Let's go to database and files. To appreciate the power of databases, it is important to understand how data are stored in the computer systems. Information about the attributes of a customer, such as name and address, are stored in fields. All the fields containing data about one entity form a record. A set of related records, such as all customer records, forms a file. A set of interrelated, centrally coordinated data files that are stored with as little data redundancy as possible forms a database. A database consolidates records previously stored in separate files into a common pool and serves a variety of users and data processing applications. Databases were developed to address the proliferation of master files. For many years, companies created new files and programs, and each time there is a need for information arose. So these are the basic elements of data hierarchy. As you can see in the figure, we have the database. So the database is composed of the different files. For example, we have the customer file, the sales file, and inventory file. Then these different files are basically composed of different records. And the following records are composed of the different fields. We have your database management system, or DBMS. A database management system is the program that manages and controls the data and the interfaces between the data and the application programs that use the data stored in the database. The database, the DBMS, and the application programs that access the database through the DBMS are referred to as the database system. So the database administrator, or the DBA, is responsible for coordinating, controlling, and even managing the database. So these are the different examples of our DBMS. So we have the MySQL, or sometimes they read as MySQL. We have the Oracle, and we have the Microsoft SQL Server. Okay, let's talk about data warehouses and business intelligence. In today's fast-paced global economy, management must constantly re-evaluate financial and operating performance in light of strategic goals and quickly alter plans as needed. Since strategic decision-making requires access to large amounts of historical data, organizations are building separate databases called data warehouses. It is not unusual for data warehouses to contain hundreds or thousands of terabytes of data. Data warehouses do not replace transaction processing databases. They complement them by providing support for strategic decision making. Since data warehouses are not used for transaction processing, they are usually updated periodically rather than in real time. Whereas transaction processing databases minimize redundancy and maximize the efficiency of updating them to reflect the results of the current transactions. Data warehouses are purposely redundant to maximize query efficiency. Business intelligence. Business intelligence is analyzing large amounts of data for strategic decision making. We have the OLAP, or online analytical processing, is using queries to investigate hypothesized relationships among data. For example, a manager may analyze supplier purchases for the last 3 years, followed by additional queries that drill down to lower levels by grouping purchases by item number and by fiscal period. We have the data mining. Data mining is using sophisticated statistical analysis, including artificial intelligence techniques such as neural networks, to discover or unhypothesize relationships in the data. So, for example, credit card companies use data mining to identify usage patterns indicative of fraud. Similarly, data mining techniques can identify previously unknown relationships in sales data that can be used in future promotions. So what are the different advantages of data systems? So first is we have the data integration. Data integration, these are master files that are combined into large pools of data that many application programs access. An example is an employee database that consolidates payroll, personnel, and job skills master files. Next is we have data sharing. Integrated data are more easily shared with authorized users. Databases are easily browsed to research a problem or obtain detailed information underlying a report. Minimal data redundancy and data inconsistencies. Because data items are usually stored only once, data redundancies and data inconsistencies are minimized. Next, we have data independence. Because data and the programs that use them are independent of each other, each can be changed without changing the other. This facilitates programming and simplifies data management. Cross-functional analysis. In a database system, relationships such as association between selling costs and promotional campaigns can be explicitly defined and used in the preparation of management reports. So this is an example of our data dictionary. A data dictionary contains information about the structure of the database. The DBMS maintains the data dictionary, whose inputs include new or deleted data elements and changes in data element names, descriptions, or even uses. So what are the different types of attributes? The different types of attributes are the primary key and the foreign key. A primary key is the database attribute or combination of attributes that uniquely identifies a specific row in a table, while a foreign key is an attribute in a table that is also a primary key in another table and is used to link the two tables. So we have here an example of an ERT. So in this example, it describes the interconnected items of interest in a certain field of expertise. An ER model is made up of entity types that define the relationships that can exist between them. It also shows the relationship of the tables and how the primary key and foreign was used to interconnect the other tables. So basic requirements of a relational database. So first, every column in a row must be single value. In a relational database, there can only be one value per cell. Primary keys cannot be null. A primary key cannot uniquely identify a row in a table if it is null or blank. A non-null primary key ensures that every row in a table represents something and that it can be identified. This is referred to as the entity integrity rule. Next, we have the foreign keys. If not null, must have values that correspond to the value of a primary key in another table. Foreign keys link rows in one table to rows in another table. And lastly, we have all non-key attributes in a table must describe a characteristic of the object identified by the primary key. Most tables contain other attributes in addition to the primary and foreign keys. These four constraints produce a well-structured or normalized database in which data are consistent and data redundancy is minimized and controlled. The referential integrity rule ensures that there are no update anomaly problems with the foreign keys. Relational databases also simplify data deletion. So this is an example of our SQL. So what is an SQL? So basically, SQL is a standard language for accessing and manipulating databases. So what is SQL? It stands for Structured Query Language. SQL lets you access and manipulate databases. SQL became a standard of the American National Standard Institute, or ANSI, in late 1986, and of the International Organization for Standardization in 1987. So what can SQL do? So first, SQL can execute queries against a database. It can retrieve data from a database. It can insert records in a database. It can update records in a database. It can delete records from a database. It can create new databases. It can create new tables inside the database. It can create stored procedures and even functions in a database. And SQL can create views in a database. It can also set permissions on tables, procedures, and even views. Computer attacks and abuse. All computers connected to the internet, especially those with important trade secrets or valuable IT assets, are under constant attack from hackers, foreign governments, terrorist groups, disaffected employees, industrial spies, and competitors. These people attack computers looking for valuable data or trying to harm the computer system. In a recent survey, 70% of security professionals expected their organizations to be hit by a cyber attack in the next 6 months. A separate survey found that in the near future, 61% of the technology experts expect a major cyber attack that will cause significant loss of life or property losses in the tens of billions of dollars. This means that preventing attack is a constant battle. So let's talk about the different examples of computer attacks and abuse. First, we have your hacking. It is the unauthorized access, modification, or use of an electronic device or some element of a computer system. Most hackers break into system using known flaws in operating system or application programs or as a result of poor access controls. We also have hijacking. Hijacking is gaining control of a computer to carry out illicit activities without the user's knowledge. A botnet, for example, is short for robot network. It is a powerful network of hijacked computers called zombies that are used to attack systems or spread malware. We also have the DOS attack, or the denial of service. It is designed to make a resource unavailable to its users. In an email DOS attack, so many emails are received, often from randomly generated false addresses, that the internet service provider's email server is overloaded and shuts down. We also have spamming. Spamming is simultaneously sending the same unsolicited message to many people at the same time, often in an attempt to sell something. We also have, again, dictionary attack. Using a special software to guess company email addresses and send them blank email messages. Unreturned messages are usually valid email addresses that can be added to spammer email lists. Splug or spam blogs created to increase a website's Google page rank, which is how often a web page is referenced by other web pages. We have spoofing, altering some part of an electronic communication to make it look as if someone else sent the communication in order to gain the trust of the recipient. We also have the email spoofing, making a sender address and other parts of an email header appear as though the email originated from a different source. Caller ID spoofing, displaying an incorrect number on the recipient's caller ID displayed to hide the caller's identity. We also have the IP address spoofing, creating internet protocol packets with a forged IP address to hide the sender's identity or to impersonate another computer system. We have your zero-day attack, an attack between the time a new software vulnerability is discovered and released into the wild and the time a software developer releases a patch to fix the problem. And we have the SQL injection, inserting a malicious SQL query in input such as that it is passed to and executed by an application program. This allows a hacker to convince the application to run SQL code that it was not intended to execute. We have war driving, driving around looking for unprotected home or corporate address. Cyberbullying, using computer technology to support deliberate, repeated, and hostile behavior that torments, threatens, harasses, humiliates, embarrasses, or otherwise harms another person, wireless networks. We also have sexting, exchanging sexually explicit text messages and revealing pictures with other people, usually by means of a phone. And we also have the software piracy, the unauthorized copying or distribution of copyrighted software. Let's talk about social engineering. So it is a technique or psychological tricks used to get people to comply with the perpetrator's wishes in order to gain physical or logical access to a building, computer server, or network. It is usually to get the information needed to obtain confidential data. So there are 7 human traits to entice a person to reveal the information. First, we have compassion. It is the desire to help others who present themselves as really needing your help. Next is we have greed. People are more likely to cooperate if they get something free or they think they are getting a once-in-a-lifetime deal. Sex appeal. People are more likely to cooperate with someone who is flirtatious or viewed as hot. Next, we have sloth. Few people want to do things the hard way, waste time, or do something unpleasant. Fraudsters take advantage of our lazy habits and tendencies. Next, we have trust. People are more likely to cooperate with people who gain their trust. We have urgency. A sense of urgency or immediate need that must be met leads people to be more cooperative and accommodating. And we have vanity. People are more likely to cooperate if you appeal to their vanity by telling them they are going to be more popular or successful. Policies and procedures to help minimize social engineering. Okay, first, never let people follow you into a restricted building. Next, we have never log in for someone else on a computer, especially if you have administrative access. Never give sensitive information over the phone or through an email. Never share passwords or even user IDs. Be cautious of anyone you do not know who is trying to gain access through you. So I want you to read this code. The websites that are the most dangerous fraud and security risks are porn sites and software sharing sites. Close behind are social networks such as Facebook, making social media the new fraud frontier. Social media is the new fraud frontier because of the following reasons. First, people are more likely to disclose personal information to friends on social networks. Second, many people do not properly protect the information they post on social network sites. Third, people use the same password since remembering separate passwords for every site is too much hassle. Fourth, Facebook fraudsters also use a variety of phishing attempts disguised as Facebook games or widgets that require personal information to be disclosed. For example, suppose someone challenged you to find out who knows you best by posting. And number five, another approach is to send a message that says, "Look at the funny video I found of you." When the link is clicked, a message tells you to update your video player. Without adequate security software, clicking on the update installs malware that captures data on the websites you visit and your sign-in and password information. So what are the different social engineering issues? Okay, first, we have the phishing. So phishing is the sending an electronic message pretending to be a legitimate company, usually a financial institution, and requesting information or verification of information, and often warning of a consequence if it is not provided. The request is bogus actually, and the information gathered is used to commit identity theft or to steal funds from the victim's account. Next, we have the malware. Malware is the collective name for a number of malicious software variants, including viruses, ransomware, and even spyware. Spyware. So it is a software that secretly monitors computer usage, collects personal information about the users, and sends it to someone else, often without the computer user's permission. We also have the adware. Spyware that causes banner ads to pop up on a monitor, collects information about the user's web surfing and spending habits, and forwards it to the adware creator, often an advertising or media organization. Adware usually comes bundled with freeware and shareware downloaded from the internet. We have the ransomware. It is a software that encrypts programs and data until a ransom is paid to remove it. We also have the keylogger, software that records computer activity such as a user's keystrokes, emails sent and received, websites visited, and chat session participation. We also have the Trojan horse. It is a set of unauthorized computer instructions in an authorized and otherwise properly functioning program. Another is we have time bombs or logic bomb. It is a program that lies idle until some specified circumstance or a particular time triggers it. Once triggered, the program sabotages the system by destroying programs or data. Next, we have the backdoor, or what we call the trapdoor. It is a set of computer instructions that allows a user to bypass the system's normal controls. We have the packet sniffers. These are programs that capture data from information packets as they travel over the internet or company networks. Captured data is sifted to find confidential or proprietary information. We also have the steganography program, a program that can merge confidential information with a seemingly harmless file, password protected the file, and send it anywhere in the world where the file is unlocked and the confidential information is reassembled. The host file can still be heard or viewed because humans are not sensitive enough to pick up the slight decrease in an image or sound quality. Worm. It is similar to a virus except that it is a program rather than a code segment hidden in a host program. A worm also copies itself automatically and actively transmits itself directly to other systems. So how do we keep your computer virus-free? So first, install reputable and reliable antivirus software that scans for, identifies, and destroys viruses. Use only one antivirus program. Multiple programs conflict with each other. Do not fall for ads touting free antivirus software. Much of it is fake and contains malware. Do not fall for pop-up notices that warns you of horrible threats and offer a free scan of your computer. Make sure that the latest version of the antivirus programs are used. Scan all incoming email for viruses at the server level, as well as at user's desktop. All software should be certified as virus-free before you load it into the system. Check new software on an isolated machine with virus detection software. Have 2 backups of all files. If you use flash drives, do not put them in strange machines. They may become infected.